Okay, so MAC 248 production procedures on the Tuesday class on the 10th of February. What did we learn today? Well, I kind of stuck in the book here on really getting a grip on bottlenecks and constraints and how they are dealt with. We've said early on that we don't want to take a Nazi approach to bottlenecks and eliminate them at all costs. They are something we have to deal with. And when we take the attitude of we must maximize this and we must optimize that and we can't afford any inaction of any time, well, it ends up that is not far-sighted thinking. It can disrupt the flow of product through our plant to assembly when we have that kind of an attitude. There are times when you're going to need to restrain production, and there are going to be times when you need to keep, in particular, a bottleneck resource working all the time. So much so that sometimes you lose the forest for the trees and you can't see that an hour lost of production time on a critical machine is that damaging, but it is. It's an hour on a critical bottleneck resource is worth 1 hour of output to the whole plant. So I had to go into way more detail about comparing and contrasting how we deal with the bottleneck, which is we can either relieve and exploit the bottleneck so that we get slightly more flow through it. I showed 3 videos that showed 3 different ways you can tip a bottle upside down and get the water out of it at different speeds. Sometimes 30 or 40% faster in the case of holding a straw. So we take if we've identified a resource as a bottleneck, then we have to get as much production out of it over the time, and to keep the flow through here constantly going, to keep it running is the most important thing with the bottleneck. However, if it's a non-bottleneck, then we don't want a bunch of inventory coming through a non-bottleneck and piling up in front of assembly. We don't want that. So I talked about all the things that we did, and those things are between pages 171 and 191. And those were the efforts to exploit and relieve. When I'm talking about offloading or elevating the constraint, I'm talking about on the when they bought the Smegma and Screwmeister and one other machine to offload work from the NCX-10 and get it to assembly. 3 machines over here working the old way with old mass production methods to get the parts to assembly, and therefore they are increasing capacity significantly. Here it's not very significant increase in capacity, but every little bit helps. However, when we offload, we can get significantly more capacity. Also, 3 machines making our bottleneck parts means that if one of them breaks down, we're still making parts. If we have one bottleneck resource and it goes down, we're not making any parts. The bottleneck is shut off. So I'm not going to go into detail about the other relieving methods, but that's what happened on the NCX-10. So today I've talked a lot more about the heat treating bottleneck, and the same things are done here with the heat treating bottleneck. I told you about Ted Spencer and how he was not helpful in getting ideas to elevate or exploit this bottleneck. He's on page 185. Ted Spencer makes a nuisance of himself and tries to throw a wrench in it. Why? Because the heat treat area is not glamorous. It is a hot, dirty, and dangerous place, and when the ovens are cooking, the workers are bored, and he was letting people go for 4 or 5 hours, and we were getting no throughput, nothing going through the ovens. So it all came about because Ralph Nakamura came into his area and asked for data. It turned out the process was not being constantly watched, and they would load the ovens and go do something else, and therefore delayed parts going through that oven. which led to Ralph seeing on his printouts that he wasn't getting the production that he should have if things had been running normally. So they eliminate the delays. Ted Spencer is later on replaced by Mike Haley, who has all kinds of great ideas. They notice all of a sudden they're getting 10% more flow through the heat treat area because of what he's doing. And what is he doing? He is splitting and overlapping loads. He is putting like parts together with the same kind of heat treating. And then he's sorting and stacking them in front of the oven so that they're ready to go. As soon as this one's done, another one goes right in. That stuff had not been happening before. And finally, he comes up with a really good idea to save a half an hour at a time or get an extra heat out of every day or once a week by making tables to slide and quickly load and unload these ovens to maintain the flow through the bottleneck. He gets rewarded for that, and that was a realistic part of the story. If you can save the company money with your ideas and they are receptive, then they should reward you, and they often do. The lesson there was Mike Haley, as a worker on the floor, had the best ideas about how to improve flow through his area. So they also offload the heat treat by sending it to the vendors. Surplus parts went there. And so, but one last little thing they did was they were sending parts through the NCX-10, and they were taking deep cuts. And because they were taking these deep cuts, they had to go to stress relieving. Well, they figured out that with a little bit more time on the NCX-10, they could save hours of these parts going through these ovens when they didn't need to. They went back to the old way of cutting metal on the NCX-10, and they offloaded those parts from the bottleneck that is the oven. We then talked for quite a while about how they have a party in the place because they are getting 12% less inventory piling up in the plant. They're getting 57 orders done where they were getting 37. They shipped $3 million worth of product to get paid for as opposed to the previous best of $2 million. So they are justifiably happy. Then that is cut short quick when Stacy notices that she thinks the bottlenecks have spread. Well, it turns out the bottlenecks have not spread. What they're seeing is inventory piling up in front of non-bottleneck machines. And that's because they are overproducing on the non-bottlenecks, and they're disrupting the flow through the plant, and things are not making it to assembly because they're clogging up the pipes. I want you to read those pages very carefully. Those pages are from 195 through 210. Why is it inefficient to keep everybody working diligently fast all the time? We ended up with some, I think, really good discussions from students that told about their experiences at work in a nuclear power plant where this ethic of keeping everybody busy causes quality problems. There was a guy who worked at Terex who talked about their inability to listen to ideas from the floor being one of the reasons that plant shut down. We heard from a student who thought that the people in the book are really behaving in a stupid fashion, in that stupidity defined as doing things out of your own best self-interest. They don't care about their plant going down at first. They have to be made to care. And the bookkeeper has to get excited about the idea of the place shutting down before he can start giving them helpful hints and good data about whether they're actually making any money or not. So I thought those were all valid points about it. I ended up with a discussion of how we can apply the bottleneck to other problems in our life, even my little problems delivering machining instruction to people. Where are the bottlenecks? Why isn't it getting through to them as soon as we need it to? What can we do to relieve the bottleneck in delivery of instruction, for instance, to new guys who are learning how to program a milling machine when they used to just run a conventional milling machine. So I think it was a great day today. This was our best class in a long time. I hope to keep these discussions up because I get a lot out of that, and I know that it really helps to this class. So we'll see you this Thursday, and we'll be starting a new milestone, which will be the particular improvements and how they measure their effect on the bottom line. Thank you.